So welcome back friends. In continuation with the previous class wherein we have started with your HSI model, we went through various things. We started with this diagram wherein we tried to show your RGB color palette into a color cube, right? So thereby we also went through why this HSI model is required, and we went to this slide wherein we tried to draw a line which would join your black and white surfaces. Thereby, after joining the line, we tried to pass a perpendicular plane. By passing the perpendicular plane, what we tried to do? We tried to get all the colors with the help of your three primary colors, which is red, green and blue. Okay, so you can see this triangle here. This triangle has three basic corners. What is this triangle telling you? It tells us that one edge is at black, the other edge is at magenta, and the third edge is at cyano. Okay, so when you go on rotating this triangle, then you will be getting n number of colors right from cyana and up till it moves to your green, or when it moves back to black. So in order to understand this in more detail, we'll move to the next very important diagram. Here what we have done is, in the previous slide, we saw the hexagonal shapes, and thereby from the hexagonal shapes we got the triangular shape. But what could be seen here in the next slide here is, we have just sliced them, all the hexagonal shapes, into cubes. You can see the first 36.13a, that we have sliced them into a cube. Okay, even here the cube is in the form of the hexagon itself. That is, you can see it has six sides, 1 2 3 4 5 6. Okay, then the one major thing you need to see in this plane is, if you see the primary color, let us start from the first primary color, which is the red color. Then we will move to the next primary color, which is green color. Then you can see that the red and green are separated by an angle of 120 degrees, right? Next you go to from green to blue, then the green and blue are separated by an angle of 120 degrees. Similarly, if you try to find a relationship between the primary and the secondary colors, you can note that the primary and secondary colors are separated by an angle of 60 degrees. That is red and yellow, the first primary and the first secondary. You can see that the difference between both the colors is 60-degree angle. Okay. And one more very important thing, if you try to find the relation between different secondary colors, then you can find out that they are again 120 degrees apart. If you see the relation between yellow and cyana, then again you can see there is 120-degree difference. I am speaking of the first figure. Till now I spoke of this figure, the first figure, that is A figure. Next, we'll move it with the next figure, that is the below figure, this one. That is this figure. Okay, so if you observe this figure, that is the B figure, here you can see there is the same hexagonal shape is there, but the color point is shown as a dot. You can observe here there is a dot here. Okay, so what this dot is doing then? This dot is nothing but it tells you it is one of the color point, or sometimes you also say that the hue of the point is determined by the angle from some reference point. From that point we will be drawing some reference point, then that would give you your hue of the angle. Like, it means that it is nothing but, one second friends, yeah, so it means that it is nothing but, this is the point which I am telling you. From this point, if you want to map to any color, say for example I want to move to red color here, then from this point to this red color, this point, this angle whatever is forming, this angle whatever you can see here, that has been shown with the arrow, that gives you hue, the hue of the figure. Okay, now that means, say for example the angle is 0 from the red axis, then we say that the hue is 0. Like, say for example, if the dot is exactly on the point where we have written red, this point, I am speaking of this point, if the point is exactly at here, then the angle is 0. If the angle is 0, then we say that the hue is 0. Okay, now similarly, next very important thing is we need to find the saturation. Now what could be the saturation? Saturation is nothing but it is the distance from the vertical axis, which is usually the length of the vector from the origin to the point. So that means, say for example, I take the origin as at this point, then the dot which I have drawn is here, then the distance from the dot to the origin is nothing but your saturation. We call it as saturation. Now we have defined the origin, we have defined your saturation, we also defined the hue point. So the important components of your HSI are nothing but your vertical intensity axis, which is nothing but the length of the vector to a color point, whatever the length you have from the vector to a color point, and the angle which makes it with the red axis. This is nothing but it tells you the what are all the components. So therefore we can say that HSI plane tells us the hexagonal, as well as it could be also described in the form of a triangle, or it could even be described in the form of a circle. Whatever we have done in the form of the hexagon in the first figure, that could be done in the form of a triangle or even in the form of a circle. You can observe here. The same thing has been drawn in the form of a triangle. The same thing has been drawn in the form of a circle. Okay. Now, here again on all the three figures, one very important thing here is the reference we have taken is red. The reference point we have taken is red. So therefore you should always maintain that reference, which is nothing but the first primary color, which is nothing but your red color. Okay, so the shapes doesn't matter. Whatever shapes you want to do, you can do. There is no important thing, there is no problem with that. One very important thing is why we need to do is because here all the geometrical transformations would get wrapped into another one. So one after the other, all would be getting mapped. Okay, so the same thing we'll try to see in the form of a color. So you can see here the same thing we have tried to map it in the form of our color triangles as well as on the circles. So if you observe it carefully, here you can see you have a triangular as well as you have a circular color plane, and finally the circular color and the triangle are kept perpendicular to the vertical axis. I am speaking of this thing. One second, friends. Yeah, I am speaking of this thing. So what we have done here, we have taken both circle as well as triangle and we are kept perpendicular to one another. So you can see here you have a circle here and you have a triangle here. So one triangle is perpendicular to the other triangle. Similarly, one circle is perpendicular to the another circle. So that's what he is trying to tell us. Okay. Now, very important thing here is what we are trying to do. We are trying to compute your RGB to HSI and again back to the pre-pixel basis. That's why we can see here some of the XY components have been clearly omitted out. Okay. Now, one very important thing here, friends, is whenever you try to convert this, we would like to normalize your RGB values. That is, say for example, I have 0 to 255 values, then that has to be normalized to 0 to 1 value. Then only it would be very easy for us to do all the conversions. Okay. Now, moving ahead with the next very important thing, whatever you can see here, whatever the planes which you can observe here, these are nothing but your HSI values. Now, if you observe the first diagram, so I am trying to tell you that this whole figure tells you about HSI, which is nothing but hue, saturation and intensity, which we have got from your RGB values. And what are these RGB values? Where did we get these RGB values? We already got these RGB values in the previous figure, right? So the previous figure is something like this. One second, I'll show you the previous figure. Yeah, the previous figure from this RGB space. How did we get this? We'll try to again, I will try to again explain you. So the first image, whatever the first image you saw here, that is this one. Yeah, this one. Okay. So this first image, whatever you can see on the slide now, this image. Okay. So this image, this is nothing but the hue image. Remember, friends, 6.15a is nothing but your hue image. Then how did we got this hue image? That I'll try to show you. One second. Yeah, I'm just going back. Yeah. Okay. So let us move to this thing. So if you move to this thing, Yeah. So I hope it's visible now. One second. Yeah, let us consider this thing only. Okay. So now the both are same. Whatever the figure you see here, this as well as this, both are same. Only where we have the pellets, here it has been drawn in the plain colors. Okay. So now, how to get that hue image is nothing but it's very interesting. What we'll be doing is we'll be drawing a line along the 45-degree line. We'll draw a 45-degree line from the red plane, which is there in the front of the cube. Now, from the front of the cube, what we'll be doing is we'll draw the red line to the white vertex. Like I mean to say something like this. From this red plane to the white light here. From the red to the white, we'll draw a line which is a vertical line of 45 degrees, you can say, approximately 45 degrees. Then what we'll be doing is, starting at that point, what we'll be doing again, we'll come back to the middle of this line. From this line, we'll come back to the middle of this line. From the middle of the line, what we'll do is, we will select a point which is there in the middle and draw a part to the right. That means we'll move to the right, something like this. Then we move around this cube something like this. We will revolve around the cube and then we will reach back to the same point. So when you reach back to the same point, something like this, it tells you it covers almost all the colors in the path. Like starting from the first color you will be getting here is yellow, next you will be getting is green, then sienna, then you have the blue, then you have the magenta, black, and finally it will again come back to red. That means once you revolve this cube, you will be getting all the colors. So now I hope you understood how we get the hue plane. Whatever the hue plane we saw just now, yeah, this is your hue plane, the first figure. Okay, the hue plane is nothing but it is a line which is drawn along your RGB plane. That's why you can see here a line here like this. You can observe this thing. A line is there, and this line is nothing but it has been moved something like this. That's why you can observe this is how you will be getting your hue plane. Okay, now the next very important thing here is, if we move to the next plane, which is next diagram, which is nothing but the saturation plane. Okay, now in saturation plane, what we'll be doing is, we need to move from 0 degrees to 36 degrees Celsius, and we already seen in 6.15a that the lowest value is represented by black and the highest value is represented by white in a grayscale image. I am speaking of grayscale image. The lowest value is nothing but your black and the highest value is nothing but your white. Now, in fact, the hue image has been normalized already from 0 to 1. That means we don't have 0 to 255, we have only values from 0 to 1. So therefore you can see in your B figure that the darker values are towards the white vertex of the RGB cube. So you can just observe here, here you can find the darker values which are there at the white vertex of the RGB cube. So this tells us that these are less saturated as they approach towards the white. Okay. Finally, in your 6.5c, whatever you can see here, the cube, it is nothing but the average of all the RGB values at the corresponding pixel. So when you have all the RGB values at the corresponding pixel, then you will be getting something like that. So whose average it is? It is nothing but the average of your RGB plane. So what is RGB plane? RGB plane is this one. Whatever you can see in this slide right now, it is nothing but the RGB plane. So I hope friends this is clear till now. Whatever I have covered, how all the three planes are obtained, that is hue plane, saturation plane, as well as the intensity plane. Okay, so here I'll be stopping my today's class. Again we'll meet in the next class, wherein we'll try to cover the next very important thing, that is how to get your HSI component images. Okay, thank you for watching. So if you have any doubts, please contact me. I will be always happy to help you. Thank you.